And I'll introduce Rohit, who will be talking to us about the TupleJump data engineering platform.
So, hi, I'm Rohit. Oh, that's loud. So I'm a software engineer and currently trying to don the hat of CEO at TupleJump. Along with me is my friend, colleague, co-founder, CTO, Satya. And we are here to tell something about what we are doing with Spark and integrating it with Cassandra and stuff like that. So a couple of years back, we started ideating on a concept that we should have a big data platform that makes the developer's life easy. A developer doesn't have to go out, assemble different components and build upon it. He should get things out of the box. And while working on this idea, we got a chance to work on a project where we used Spark against Cassandra. And after years of pain in dealing with Hadoop and the ecosystem, it felt like a breath of fresh air. So we loved it so much that we decided to quit our day jobs and go full-fledged out and build this framework so other developers also feel the love. And we are hoping the same here today. So what we do is we have built a platform which takes care of your big data pipeline, which Satya will be explaining in a while. So, and we work with different startups to begin with to build their solutions, their big data applications over the platform. And for a company of our size, we are roughly 7 people today. And we have achieved 2 deployments in last 8 months. And 1 is going live next month. So that has been our achievement. I'll leave to Satya to walk you through the big data pipeline.
Hey, so most companies, they start out with ad hoc collection infrastructure, and they later on try to discipline it. They then usually deal with transforming data using MapReduce, and then they typically write their MR jobs to explore and report on their data. And then that's when they get ambitious and they start looking at the ML side of things. Some people touch Mahout, some people write their own stuff. Meanwhile, the ops guys, they've already lost their personal lives. They've written these deployment jobs 10 times over, the deployment scripts 10 times over. And so what we went ahead and we did is we experimented with all that. We've been through the process. We have a consulting background. And so we've experimented and we've built it with the best of breed solutions as of date. And we think you're going to like it. So it starts with Hydra. This is our collection framework. It's powered by Akka. You can do a per message processing, or you can push batch jobs via Spark streaming to be analyzed in Spark. So we use it for a variety of needs. Currently, we are using it for sensor data collection, click logs, and so it has got good Spark streaming support. Then Calliope is our Spark and Cassandra integration. It's open source. You can use it to read and write data into Cassandra. You can also, again, join Delta transformations on real-time feeds using Spark streaming. Then we've enriched Cassandra. So Stargate is our search server. It's indexing mechanism that we built into Cassandra. And SnackFS is a HDFS compatible file system on top of Cassandra again. it's comparable to the CFS that DataStax provides. So moving on, if you want for your exploration needs, we use the regular the shard distribution. We have our own fork of the shard, which we've stabilized a little bit. With Calliope, the advantage you get is with the indexing built in, you can filter out the data in the Cassandra layer rather than reading all the data into the Spark layer. Yeah, so you can save a lot of time in your batch jobs. You can do more towards interactive analysis. And then UberCube is it's a patent pending technology. It's a distributed OLAP cube engine, and you talk to us to know about it, to know more about it. And then Minerbot is built on the Spark ML lib. We are taking it to the next level. We've got our own deep learning framework. We want to get to a place where you can actually drag and drop and do machine learning. Long shot, but we'll get there soon. And then to complete the puzzle, we have a visualization front end. It's called Pissarro. It's not just reports. You can build dashboards and all these stuff. So our customers have built their solutions on their front-end solutions on using using this technology. And then finally, yeah, ops guys, we love you. So we've run ops for clients earlier. So we know how much pain it is, and we want to make it as simple as possible. Click to cluster, maybe click to add more machines. We are going to have a PaaS offering very soon. You guys should check it out. So we've thought about all the things we could coming from the consulting that we've done over the years, and we thought we have some it's a great set of advantages to give it out to people. So I'm just summing it up there. I'm not reading it out from the slide. Rohit is going to talk to you about how our customers are actually using our stack right now. So we've got a couple of case studies, which Rohit will tell you more about.
So yeah, that's what we built. We started building it around 1.5 years back, and we started a company around it in May in India. And the first customer that we got was IoT thing. For those who don't know it, it's Internet of Things or M2M, and it contributes most of the data to the big data pie. And there are more and more devices coming up daily, which push data to the cloud. People are collecting this data, and everyone wants to do something new with this data. So did our customer. They are basically into manufacturing a complete sensor package. So it has a camera, mic, and humidity sensor, temperature sensors, everything built into it. And it keeps on pushing data to the cloud continuously. When the data from that comes to the cloud, you need to do an anomaly detection in that. You need to figure out if something has gone wrong somewhere and alert the user accordingly. Over a period of time, we need to collect this data and do anomaly detection on batch. So this was one flow where we required processing one message at a time, processing a stream of message, as well as processing batch of messages that have been persisted over time through ML. And finally, we needed to visualize it so that the providers who have who are selling the cameras, so many a times these people white label the cameras and other people sell it. So they want in detail information as to what's happening on the devices they have sold, how are they performing, they have motion detection algorithms and noise detection algorithms, are they performing as expected, or they are giving fake alerts. So all those kinds of reports need to be done. So that is what we do with it. So yeah, why TupleJump was a good fit for it. So when we started building Hydra, our target was getting sensor data in. Our target means, for me, I consider everything to be a sensor which is pushing in data. It can be a browser, it can be a laptop, a device, a server sitting in your cluster, or cameras in this case. And so it was designed for getting sensor data in. Then in most of the cases, means people do say that we don't need per message processing, but in most of the cases you do need per message processing. So that was also baked right into Hydra. I'm sorry, I lost the flow there. Okay, so regarding the number of events coming in, we get over some 7,000 to 8,000 events coming in per second, and we needed a good storage mechanism to write to it. And there we had dstore. That is our Cassandra plus our enhancements built into it. We had MinerBot, which was actually custom algorithms built for machine learning before MLlib came. We have mostly given up on those algorithms, and we are moving to MLlib now. And yeah, finally we used Pissarro for the visualization. This project was started as a POC. When we talked to the customer, we just said, hey, let us do the POC. Then we can decide on whether you want to go with it or not. And within 4 months, the actual cloud was live and working. Today, it serves over 2.5 million cameras connected and pushing data in real time. The second case study is about the customer we are going live with by end of January. And they are building an advertisement exchange. So in this advertisement exchange, we need to get user clickstream from all the properties that these customers, the client supports, as well as client's partners support. So they get a few billion clicks every day. And at the same time, we need to get the user demographic data from different sources, and the advertisers make their own configuration regarding what ads should be served where. When the clickstream comes in, based on certain rules, we decide whether it has to go to the RTB engine, that is real-time bidding engine, or it has to go to the ad engine, which decides on basis of certain rules as to which ad it should serve from the existing inventory. In case of RTB engine, it broadcasts the auction, and we start getting responses, and we have to make a decision within, I think, some 100 milliseconds or something like that. Yeah. So we, and over time, to improve the performance of the quality of the ads delivered and the response people are getting to the ad, we do some algorithms on the stored data over time, based on, depending on the user action and different things, to keep on optimizing the rules engine. And finally, means advertisers do love their reports, so we provide that. Again, I won't drag you through the whole story again. We used Hydra for collection and event processing. We used MinerBot for algorithms, and Pissarro for the visualization. So yeah, those are the two case studies. And I think we don't have time for questions, but you can mail us and you can get one of these t-shirts.